Okay, all right. Who missed something? You gotta tell me which quiz you had. I think were they 1 heart and 2 heart? Here it is. Yeah, 1 heart or 2 hearts. So tell me which quiz you had.
11 on the 2 heart.
2 heart, number 11, where it says find X. All right, so let's look at the problem. Okay, so if we're gonna find X, we need to figure out what function we're going to use. We're going to use sine, cosine, or tangent, and we need to figure out which one it is. So here's your angle. Never use the right angle. Here's your angle. Which side is this? This is opposite. With regard to that angle, this is opposite, and this is adjacent. So which function will we use? Sine, cosine, or tangent? COA. So tangent 18 equals x over 4.2. Remember, the angle is always what's hooked to the function. So the 18 is not going to be part of the fraction. The 18 is hooked to the tangent. So tan 18 equals x over 4.2. So x is just going to be 4.2 tan 18. So I'll make sure my calculator's set in degrees. It is. And I'll take 4.2 tan 18. And how am I supposed to be rounding 1,000? So I got 1.365. Did you find your error?
Yeah.
Okay. All right, who else? Something you missed and you're not sure why. Peter?
9, 1 heart.
1 heart. Number 9. We want the navigational angle for east, southeast. So we're looking down here. So this would be southeast. That east side of southeast would be here. This is east, southeast. So we want this angle. We always measure from due north. So we know these little splits, when we divvy them up, are 22 and a half. Because the main split's 45. So we have 90 and 22 and a half. So it is at 112.5 degrees. Okay, perfect. All right. Yes, Jackson?
12 on the 1 heart.
A hawk in the top of a tree.
Yes.
So the tree is 23. The mouse is on the ground. The angle of depression is 19 degrees. Kids, we talked about this, that when your problem involves an angle of elevation or depression, always put it here, because it's the same thing. The hawk looking at the mouse and the mouse looking at the hawk have the same angle. So just put the 19 here. How far is the hawk from the mouse? So again, with regard to this angle, which side is this? Which side is this? So what function, if I'm doing opposite and hypotenuse, I will use, so sine 19 equals 23 over x. Get rid of my fraction and divide. So x is going to end up being 23 over sine 19. So 23 divided by sine 19, 70.646. So 70.646 meters. All right, Jackson? All right, who else? Anything you missed that you're not sure why? Hey?
What was the answer to 6B on the 1 hearted?
1 heart, 6b says find the cotangent of 3. Now, there's no degree mark on that, so my calculator is gonna have to be set in radians. And I don't have a cotangent button, so how do I get a cotangent into my calculator? 1 divided by tangent. So 1 divided by tangent 3, it should be negative 7.015. Okay? All right, anybody else?
Can you do number 8 on 2 hearts?
8 on 2 hearts. I'm gonna use the same picture I used here,
Yeah.
only it's this angle this time. This is the south side of southeast. So this is the angle I want. So I don't know, there's different ways you can do it. Straight south is 180. This is 22 and a half. So I could do 180 minus 22 and a half. Or I could do 90 plus 45 plus 22 and a half. Any way you do it, I think it's 157 and a half. If I subtract it right.
Okay.
Okay?
Yeah.
Can I ask, on one heart, number 1, what the opposite number was?
We gotta do our Pythagorean theorem. So this is 2, this is 3. That was given, right? Cosine was 2/3. So the Pythagorean theorem says 2 squared plus b squared is 3 squared. 4 plus b squared is 9, b squared is 5, so this is the square root of 5. Now, those of you that put the square root of 13 there, first of all, crazy. But second of all, the square root of 13 is bigger than 3. Can this side be more than this? No, that doesn't even make sense. When you do the Pythagorean theorem, the hypotenuse is here, always. Draw your picture. All right? Anything else? Okay, okay. Let's get back to our action here. What we were in kind of the middle of doing was some graphing. And I think we had talked about the impact of a number out in front, right? What did we say about a number out in front? What does that number do? Robbie? Yeah, well, it multiplies the amplitude. So depending on the size of the number, it could actually smash it. But yes, it multiplies the height. This number multiplies the height. Now, what about, which is called the amplitude in trigonometry? Now, what about the negative? What is that makes it go upside down. So, keep in mind that your standard, regular, generic old cosine looks like this. This is your cosine curve. Starts at the top of the hill, got half a hill, a valley, and the other half of the hill. If I turn that upside down, then I'm going to start at the bottom of the valley, and I have my hill, and then I have the rest of my valley. So this is the upside down of the cosine. Normally, my amplitude is 1, but because of the 3, it's now going to be times by 3. So my amplitude is 3. Now I have I done anything to alter my horizontal labels? Nope. So they are, as they always are, 90, 180, 270, 360. Make sure, cosine is weird to draw, I totally get it. When you draw the standard period of cosine, make sure that you are ending where you started. So I started this one upside down at the bottom of the valley. So it has to end at the bottom of the valley, that will be 360. Oh, shoot. We're in radians, sorry. So it's not those, it's the radian equivalent of those. I gotta switch gears here for class. Yep, there we go. Sorry about that. So my period is 2 pi. Now, these are the same as 90, 180, 270, and 360, right? But those would be degree measures and we're graphing in radians. Because that's what big kids do. All right, everybody okay with that? Because now we're taking it up a notch. What does that number do? I know what this one does. This one's going to multiply my amplitude. So my sine curve, this is a sine curve, has a hill and then a valley. Its amplitude will be 2. Everybody okay with that? Now, just like with the cosine, the normal labels, and I'm going to write them down here. I'm going to put my final answer up here in my picture, but my normal labels are pi over 2, pi, 3 pi over 2, and 2 pi. Those are the normal labels for sine and cosine. But what's happened to them? What does this do? This alters the horizontalness of the picture. While a number in front multiplies the amplitude, this number actually divides the period. This divides the width, which we're going to call period in trig land. Okay? So this number is a multiplier, so these were 1, now they're 2. This is a divider, so dividing by 2, I have to take each one of these and divide by 2. Now, since fractions are involved, you might think about dividing by 2 as being the same as multiplying by 1/2. That's up to you, but somehow you got to figure out what pi over 2 divided by 2 is, and that's pi over 2 times 1/2. So this label is now pi over 4. This one's pi over 2, that one's pretty obvious. What's this one? It's 3 pi over 2 times 1/2. 3/4 pi. Or 3 pi over 4. 3/4 pi is fine. And then the last one is pi. So the period, remember in the beginning, was 2 pi. Well, what have we done? We've divided it by 2, so now the period is only pi. Half of what it was before. All right. Now, this is big time now. This is major. Who remembers, well, first of all, what do we know? We know this is going to multiply the amplitude. We know this is going to divide the period. Those are the rules. We just got to memorize them. Just same as they were back in chapter 1. What about that? What does that do? Shifts it. Horizontal shift. Minus pi over 4 means we're actually shifting to the right? So what does that mean in terms of my picture? It means that your sine curve, which was supposed to start here, is now going to start over here somewhere at pi over 4. So this is going to be the beginning point of your sine. It's a positive sign, so it's going to have a hill and a valley, and it's going to end right there. Are you still with me? Now, I know that my amplitude is going to be 3. Does everybody have that? That's easy, right? We multiply 1 by 3. I know that the period of the real normal sine curve is 2 pi. That's the normal period. What have I done to this period? I've divided it. So all the horizontal labels are going to be divided by 2, right? So my period now is pi. From here to here is pi. Now put your thinking caps on. It's very logical. This is a fourth of a pi. So think of it as a fourth. From here to here is 1 pi. So I'm starting at a fourth and I'm going 1. Where will I end if I start at a fourth and go 1 whole unit? Where will I end up? 5/4. Because 1/4 plus 4/4 is 5/4. This tells you the distance, start to finish. Since I started with a head start, a 1/4 head start, I'm going to end at 5/4, 1 1/4. Now, this is smack dab in the middle of 1 and 5. What is the midpoint or the middle value of 1 and 5? 3. Kids, this isn't a hard question. What's the average of 1 and 5? 1 plus 5 is 6, divided by 2 is 3. So this point is 3/4. This one is smack dab in the middle of 1 and 3. So what's the midpoint of 1 and 3? 2. Now, I am not going to require you to simplify these fractions. We're going to be doing a lot of fractions. If you want to simplify, make this pi over 2, that's fine, but you don't need to. There's enough to keep going here. We don't need to worry about that. This one is the middle of 3 and 5. So it's 4/4, or just plain pi, if that's how you want to think about it. Wow. Amplitude's 3. Period is pi. And what we call the phase shift, or the horizontal shift, you can use either word, I don't care. In trigonometry, we normally call it phase shift, but it is a horizontal shift, is pi over 4, positive pi over 4. Who remembers how we get a vertical shift? What do I do to my equation if I want to pick my picture this way? Anybody remember?
Add at the end.
You put a number at the end. So like if we put a +1 here, that would take this picture and pick it up 1 unit. Remember that? That's called a vertical shift. All right. Boy, this is thought-provoking. You really have to keep yourself together here. All right, what's next? 1/5 cosine 1/2 x plus pi over 8. This is a cosine. Again, I just like to have in my memory, there's what that's it, that's what I'm drawing. Be careful though, because while normally I would start it right here, I can't this time because of this. What does that tell me? Okay, this one's gonna go to the left, pi over 8. So over here somewhere is pi over 8, and that is where my cosine's starting. Now remember, your cosine starts at the top of the hill. So the top of the hill is right here. So I'm gonna go ahead and draw in my shape. And if it starts at the top of the hill, it must end at the top of the hill. I know that's a very strange picture, but that's it. That's what it is. Now I need to figure out where I cross, my minimum, my low point here, and where I end. Those labels depend on my period. I know that my period is supposed to be 2 pi. Every cosine and sine starts with 2 pi as your normal period. This number divides the period. So if my normal period is 2 pi, this picture will be 2 pi divided by half, which is what? 4 pi? Now here's where our logic comes in. Here to here is 4 pi. Can you tell me what that is right there? Don't say 4 pi, because you didn't start at 0, you backed up. So what would that one be? Come on, let's think. I heard someone say something, but I couldn't understand it.
Say it with your chest.
Say it with confidence, folks. It's 31 pi over 8. Why is it 31 pi over 8? Well, isn't 4 pi the same as 32/8? (32 divided by 4 is, or 32 divided by 8 is 4. So if I have to start at -1 and travel 32, won't I be at 31? This guy is smack dab in the middle of -1 and 31. So what is the average of -1 and 31? Well, -1 plus 31 is 30, and half of 30 is 15. This is right in the middle of -1 and 15. What's the average of -1 and 15? -1 and 15 is 14, and half of 14 is 7. And guess what? That one is in the middle of 15 and 31. So 15 and 31 is 46, and half of 46 is 23. Everything is evenly spaced. Everything is 8/8 apart. It's a lot. It's a lot. All right, let's try one more together and then we'll see if you can do one by yourselves. All right, so here we go. Y equals negative 2 sine 1/3 x minus pi over 7. Now I like to remind myself what a sine looks like. A sine looks like this, right? But there's a negative in front, which means it's going to look like this. And there's a phase shift, or a horizontal shift, of pi over 7, which means everything's going to start at pi over 7. I guess we just put pi over 7 over here somewhere. So it's negative. Looks like that. Everybody still with me? You need to find this label, this label, this label, and this label. Those are our quadrants, our sections of the sine curve. It all sort of hinges on what the last one is. And that one depends on what the period is. What's your period supposed to be? In a perfect sine world, the period would be 2 pi. But you have changed that by dividing it by 1/3. So what is your period? 6 pi. And 6 pi is 42 pi over 7. You don't have to think of it that way, but I think that makes it easier because we're going to start at 1/7 and travel 6 pi, which is 42/7, which is going to put me where? Yes, thank you. 43 pi over 7. You guys have to do better. I'm distracted because apparently Lenny and Lewis, or whatever their names are missing. And I didn't realize we had big bugs in the school, but apparently we do, and they're no longer in their cage. Big bugs from the science lab. Lenny and...
Are missing?
Yeah.
Oh,
Larry and Lenny. Larry and Lenny. Okay. And I'm just telling you right now, if Larry and Lenny come down this hall, I'm sorry, I don't care if they're someone's pets, they are going to get smashed. So I hope somebody finds them. All right, 1 and 43 makes 44, and half of 44 is 22. Now, this is going to be our first time. This stuff is full of fractions, and we just have to learn to deal with it. So now I'm going to find this one. So I'm going to average these two together. Averaging means add them and divide by 2. That's how you average, right? So when I add these, I get 23/7. Now I have to take half of that. Well, 23 doesn't cut in half evenly, so I'm going to have to make it 23/14. So we're averaging. So we add and divide by 2. When fractions are involved, we add and times by 1/2. Same thing here. 22 and 43 makes 65. And half of that is 65/14. Now, if this had been 66, then I would just say half of 66 is 33. But I can't do that with 65, so I have to make it a new fraction, 65 over 14.
Can you repeat that one more time? Why'd you have to put it over 14?
Because you're multiplying by half. You're adding and multiplying by half. That's how you average. You add and divide by 2. All right, you and your partner, which one is this? You and your partner are going to work on I. See how far you can get with I. Take it one step at a time. It is completely full of fractions. And I'm going to stop periodically and touch base with you to make sure that you are on base here. While you're working on this, I'm gonna come around and make sure you did your video notes from the other day, so since you're in your notes, that should be easy to do, so you did them, Amanda and John. Brady Jackson, you guys do your video notes? From the other day? You guys do your video notes? You did not. Okay, well, we call people who don't do their homework. Hurt your feelings. Although not doing the homework hurts my feelings. Oh, that's the one I need, yeah, that's why I'm confused. Yeah, that's it.
Okay. What's the usual?
Yes, they do. Oh, and you got to turn me off before we were supposed to. Interesting, you do your video notes? I said, don't act so excited. Jake, you do your video notes? Yeah. I love my Mrs. Ford, yeah, good. How about you guys?
I guess I did mine at like half of
We
it.
did this in class, how come you don't have that one done? So what's your story?
Can I give it to you on my, can I tell you?
No, you're supposed to have it done. You didn't do it. You need to watch that though, because I probably said something important somewhere in there. Did you do the video now?
Got some bad.
Was that enough?
I did these three.
So that's like a 2.5.
Well, I did 3 out of 6.
Yeah, but you did the easiest. Drew, did you do your video notes? What? Turn over and do it.
Well, I still haven't listened to the meeting, so no, not yet.
Not yet.
Not yet.
Not totally turned over?
By Monday, it'll all be.
Alright. Okay, how far did we get? Oh, I didn't check yours. Did you do your video notes? These three and these. Some of that I was wondering when you were absent. Alright, here we go. Let's see how far you got. Where's my marker? Alright, here we go. First of all, I hope that you have a cosine curve starting at negative pi over 6. The amplitude is 2/3, so that's easy points. And what's our period? Well, remember, your period is always starting as 2 pi. That's the fundamental period. This one has been divided by 2/3, which means it's been multiplied by 3/2. Did you get 3 pi for your period?
Yeah.
And you may or may not have thought of 3 as 18 over 6. That's up to you. But it is, it's 18 over 6. And since I started at -1, I'm gonna stop at 17. How many of you are stopping at 17.6? Okay, so if you're not, we need to make sure you're stopping there now because all your other points will be wrong. So we're -1 plus 18. Now, this one, and this one. Let's do the middle one first. What is the average of -1 and 17, Katie?
Oh, I just did it when I subtracted 1 from 17, since it was 1.
Uh-huh.
Shifted back. So then I got 16 and then got 2. So
Yep.
I have 8 pi over 6.
Perfect, that's exactly right. That's exactly right. And again, you don't have to reduce that. I know it reduces, you don't have to. Unless you want to. I think it's easier not to, because now we're gonna average these. And they have a common denominator, so it's easier. So -1 and 8 will be 7. Oh shoot, there's no half of 7. So it's 7/6 cut in half. So did you say 7/12? How many said 7/12? Oh, you people are my heroes, perfect. 8, if you didn't get that, pay attention, we're gonna do it again. 8 and 17, I wanna average those now. 8 and 17 makes 25. So 25/6 times a half will be 25/12. How does that look to everybody? Does that look good? You okay with that? All right, now, that takes care of the actual graphing on that section. Look at number 2 now. Number 2 is backwards. I've drawn the picture, and you're going to give me the equation. Okay. Now, what shape, when you look at 2A, what shape do you just think immediately when you look at it?
Sine.
Sine. So this is going to be a sine equation. We're going to start with that anyway. And would you agree that so far in our sine equations, we could have a number here, a a number here and a number here. Right? Now, 2 of those you can fill in right now. We know that the number out in front is going to be what? 1/5. How do we know that? Because that's how high and low the picture's going. We also know this number is going to be x minus pi over 6. Because our picture has moved pi over 6 to the right. Now, the only thing we don't know is this number. But I want you to remember that 2 pi divided by that number, I'll just call it n, is the period of the picture. That's how you find the period. You take 2 pi and you divide it by that number. Well, wait a second. What is the period of my picture? How far is it from the beginning to the end of my picture, Jake?
Is it 4 pi over 6?
It's 4 pi over 6. So 2 pi divided by n has to be 4 pi over 6. Look at your picture, guys. Everybody see where we got 4, 6? We went from 1 to 5. That's 4. Period is start to finish. So let's cross multiply. 12 pi equals 4 pi n. I'm going to divide by 4 pi because I'm trying to figure out what that n is. And it looks like that n is 3. So you're working everything backwards. Now, I don't know if you noticed this or not, but the directions said you gotta write a sine and a cosine equation. And I know what you're thinking. You're thinking, wait a minute, Mrs. Ford, this is a cosine, or this is a sine picture. Right here, pi over 6, that's a sine picture. But what if I started looking at it here? We're gonna go in a second. Could I think of it as a cosine if I started looking at it here? Yeah, and that label is pi over 3. Now, looking at it as a cosine does not change the amplitude. It doesn't change the period. The only thing it changes is where I start looking at it. These things go on forever and ever in both directions. So you can look at whatever chunk you want to look at. Does that sort of make sense? We'll do another one next time. That's it for now. All right, so what we're going to do is we'll leave everything here.
Hello to Rachel. At this time, all juniors should be heading to the WAP or the MIM. They will be presenting